There we go. Okay, close some of this up. Okay, so you may see that I added a couple things to week 3. Before it just had really just the 2 assignments here. I added these videos in just because I know some of you are following along from what Professor Steady had it anyway on YouTube. Subscribe to his channel, smash that like button or whatever they say on those things. But no, it has a lot of good stuff on there. And as I said, some of it is older from the older time, which is only a few years, honestly. But there's not that many changes. I'll mention changes that I know I noticed. Like I mentioned with the F format instead of using the other way. There may be some couple other things that I get to as well. Just kind of thinking ahead a bit from what we may even talk about today. But for the most part, everything on there is up to date. So they're good resources. So I try to put them in, especially if it fits what we're talking about or what we may get into next. Just kind of with the flow of what we're going through this semester. So what I wanted you all to do, or what I wanted to do today, was to continue where we left off. We were talking about Boolean structures. And so I'm going to open up my idle. And we were talking about if and else statements before we left. And then there was an error because of a bug. I didn't have something closed parentheses above, and so it caused an issue. So in the last video, that was why that didn't run. But let's see what we come up with today. So just to review Booleans. So a Boolean is a true or false statement. So in Python, you can actually write it true. True is true, and false is false. Notice that they change colors because there's special keywords already within Python. So, but what does this mean? Well, if something is true, it means it's true, and it's a go. Some people may think of it as a yes. Some people think of it as an on, especially when you're talking about like circuitry. Right? If you flip the switch on, you expect for the electrons to flow, and therefore you will see light. You turn it off, you expect for them to not flow, and so it's off. It's false. It's a no. And actually, for those of you that have any background in that, especially with regards to cyber and with networking, you may even think of it as ones and zeros because sometimes that's what you do for your on and offs. You have to code it as a 1 or a 0. Well, true. If I were to int, you guys remember typecasting? We can take anything of any type and place it into another type by typecasting. So we can use these functions here. So if I say int true, for instance, what that means is going to take the Boolean true and it's going to turn it into an integer. Well, I said true was like yes or like on, and I said that was represented with a 1. So I should get a 1 when I do this. Lo and behold, I get a 1. So what would you expect if I did a false here? Well, yeah, you would expect to find a 0. So that's another cool way to look at this so that you can see that it really is just an on-off, yes, no, 1, 0. And those of you that have plugs that even have a 1 and 0 on it, so you can know which way is on and which one's off, that's where that comes from. Sometimes the people see a dash and they see a circle and they think that it's like, hey, it's flowing and this is open, which is true, but it's just a 1 and 0. That's how I like to think about it. So if you ever see that on a switch, that's what it's for. That makes it easy. To me, that makes it easier to understand, especially in regards to if you have to take something from hardware and then it has to go to code, and you're trying to use the code to tell the hardware what to do. This is actually what what happens to a computer. For different switches and things that are going on within the IOs, this is actually what's used. Ones and zeros, true false statements, and that's how Booleans work. Okay, so a couple other things about this. There are 3 other keywords that usually go with Booleans, and that's OR and an XOR. So I want to talk about what these are. So if I said something was true or it was true, overall you would say the statement is true. Like my first name is Christopher, or my last name is Stevens. Well, both of those statements are true. So overall, my statement is true. If I say my first name is Christopher and my last name is Stevens, both of those statements are true. So the whole thing is true. What if I said my first name is Christopher and my last name is Leahy? Well, the first thing would be true. The second thing is false. So what do you say about the overall statement? I'll let you guys think about that. Maybe you're actually typing it into your idle and you have an answer. Think about that. The first statement is true. The second statement is false. And I just want to know, is the first one or the second one true? Would you say? Say, okay. Someone believes it will be false. Well, the answer is true. But is it just because it comes first? Well, let's see. That's a good question. It actually is not just because it comes first. It has to do with logically. If I say, okay, my name is Christopher, or my last name is Leahy. I'm just trying to see did I say anything true when I say or? If at least one of those things is true, then the whole thing is true. And that's it. Because it's an or. If it was an and, this entire thing cannot be true. Oh, we're talking about or specifically. Yes, it's gonna be or specifically. So these keywords here. So we had or here, and we have and. We'll have XOR as well. So we'll now, like I said, we'll talk about it in a moment. Um, but with or, it doesn't matter if both statements are true. You just need one thing to be true, and then the whole thing is true. Okay. Um, but with and, the both statements need to be true in order for it to be true. Now, I'm going to show you something else though here. False and false is also false. Sometimes people get confused with that because they think that, oh, if both things are the same, then it works. No. The question is if it's true or if it's false. If I say the first thing and the second thing and both parts are true, then the whole thing has to be true. If it's one true and one false, well, the whole thing's not true, so it's false. If it was false and false, obviously that's still false. It doesn't have to do with both parts being the same. It's only has to do with what is true in the statement that's been said. Okay. All right. So I'm gonna do true. Is it X capital? Oh, okay. Actually, that may not be a keyword in this one, in this version. Yeah, looks like it's not actually going to be available in this version in this way. So I'm going to use the older version of this with bits. See if this is going to work. I'm just going to actually test to see if this works. False and true. There we go. Okay. And this should actually be true. Cool. So the caret, which we talked about, has to do with bitwise. and we'll do some bit calculations. It actually can be used for XOR as well. And so what XOR is it's like exclusively OR. So true or true. Is it exclusively just one true statement here? And that's false, because there's not exclusively just one of them here. It's not a true I was gonna say that. It's not a true there's one it's not a true there's one right answer, if that makes more sense. So it makes it very exclusive. So in this case, you got two things that would be correct. Well, this is not exclusive, so it's false. It would be like if you're taking a test, you in like if it was multiple choice, you say A, B, C, or D. That would be an exclusive OR. There's no possibility of, okay, well, you could pick multiple things to be right. Because that wouldn't be an exclusive OR. That would be saying, oh, that would be a regular OR. Like anything's possible. Okay. But most time you won't use XOR within your code, unless you're doing some analytics and data sciences. Maybe you might use it, but for the most part you'll use OR and ANDs. And they become very helpful, especially when you have long sentences that you need to test. And those sentences, I mean conditional sentences or conditional statements, which we began to talk about last week as well. But just to kind of finalize, and I'll do this in a new file, we're talking about Booleans, and that is a true or false statement. And what did we learn? We learned that true is true and false is false. That OR is true if at least one option is true. And you'll notice that a couple of other words are becoming keywords. Come on, there it is. That's because they are. So is another keyword. If is a keyword, which we'll use in a second as well. And for and, both statements must be true. So and is true if all parts are true, I guess I should say. Or options. Let's do options. All options are true. So okay. I'll lowercase it because that's how it is when you type in the actual keyword. So are there any questions about these Boolean statements so far? No? Good. Good. And I guess I'll put a little tidbit in there as well about inting it. So if you int true, it's 1. And if you were to int false, you would get 0. Okay, so it's like an on or off, yes or no, 1, 0, true, false. Okay, so let's see. There are a couple examples that we can, or there are a couple of operators we can use with Booleans as well. So I want to look at those. Again, I know we've kind of already talked about these, but I just want to show it. For instance, if we were to take 2 plus 5, we know that equals 7. But if we ever want to test to see if it does, we can use a Boolean operator known as equals equals. The purpose of this is to test to see if equality is true or false. If the thing on the left is actually equal to the thing on the right. And before it does that, it actually will check for other mathematical operators. So it's going to do the 2 plus 5 first before it just goes. It's not going to do 2 plus 5 equals, is 5 equal to 7. It's going to do 2 plus 5 first. But if you ever want to be safe, you can always put parentheses around whatever on this side. And most people do that because in most languages, you have to. Python, you do not, though. So, I'm going to show you that you do not have to. Most languages, like I said, you do have to, though. So you may want to get used to doing this, and it probably will be easier on your minds and on others as well when doing so. But if I were to do, say, let's see, 2 plus 3, and say, does this equal 7? That's false. So we get a false statement. So the double equals checks for equality. If you had a single equals, you're saying it is equal to that. So you're like assigning it. That's why we assign variables with an equal sign. Okay. So there's also, since there's an equal, there's a not equal. So 2 plus 5 not equals is a exclamation point and an equal sign. So is 2 plus 5 not equal to 7? This should be false because it is equal to 7. 2 plus 5 or 2 plus 3 not equal to 7 will give us true because it is not equal to 7. So other ones for comparing, you all are used to, like greater than, less than, greater than or equal to, less than or equal to. So we won't have to go into those, but I am going to list them just so that you have them. So we got less than, or equal to, and we have greater than, and we have greater than or equal to. Okay. All right. So you can use any of those to compare two sides as well. And then this will become more helpful as you move forward, or as we move forward in this class, especially what we're going to look at very, very soon. So something else that can be used. Let's see what's here. Oh, it's not going to take it in this language. So some languages, you'll see that there's other symbols used for ors and ands. So the two vertical bars can be used for ors, and also, oops, here, this guy can be used for and, the ampersand. In Python, they wanted to just write it out explicitly because it was easier for people. And so there's the ands and ors. Okay. I think that was a good review of Boolean. Again, I feel like we've looked at this this is probably the third time. It'll come up a lot, and so don't ever feel afraid to ask me to go over stuff again with it, because you're gonna use it to test to see if you can move from one point to the next, right? You want to, if something is true, you would like to move forward to the next thing. For example, in your homework, I mentioned how you could use conditionals in order to figure out if you were to do a Fahrenheit conversion or to Celsius, or a Celsius to Fahrenheit conversion. For instance, if you ask the user to enter in whether to convert from Celsius to Fahrenheit or Fahrenheit to Celsius, you could get their input and then check to see what they said, and then that would decide what you did next, right? I didn't get the chance to look at what everyone did for their conversions. I saw what some did. But like for the most part, everyone was able to get through it. Those that turned it in, because you were looking at two different files. One you went Celsius to Fahrenheit, the other you went Fahrenheit to Celsius. Well, I mentioned this last week. How would you feel if you had to open up two different softwares to do that conversion? Wouldn't it make sense if it was all in one? Well, we can look at how to do that in a moment. And then with regards to your pennies and your pennies assignment, looks like many of you were able to either use the modulus to do remainders. Some of you did the remainder the old-fashioned way, where you subtracted off what you got when you multiplied the divisor times the quotient, which is fine as well. Some of you showed both to show that you could do both. That was cool. I thought it was really cool. I like when people show like, hey, I know I could do this multiple ways. Because that's good logical thinking. It's not necessary, but it does help you as well. Because then after that, you can start to, as you get more into programming, you know that there's multiple ways to do something. You can say, hey, which one's faster? And there are certain tools within Python you can use to actually run to see if something is faster or not. So, all right, well, let's move forward. So now I am going to talk about conditional statements. So which we use Booleans within. So a conditional statement. Um, so a conditional statement you may have heard of when you did logical statements. It used to be a part of curriculum back in middle school, elementary. I have learned that recently it's been removed, and it's usually only taught in liberal arts schools. There are very few colleges in the Maricopa Community College system that actually still teach a course with it. But I feel that I feel like they're more important because they help people understand things logically, and they're very important when it comes to programming. And so what a conditional statement is, it's very simple to understand. The word condition means that you have a condition. Looks like someone says, "Oh, struggle with using the modulus." Well, we can actually talk about that for a moment, and then move to conditional statements. So the point of the modulus was to okay, I was gonna give it a little more than that. Okay, so the point of the modulus was to give the remainder, and it would have made things faster for you all. So if you were to, for instance, just think about our problem we had. So we had 867 pennies was the example that was there. We could pick any number we want, but I like to use that one because it'll give a result for every type of currency. So 867 pennies. Well, we get that from the user. How do we know how many dollars we had? And I just know from that those of you here, you were able to answer this. So um, we divided it by 100, and oh man, we got $8.67. That's what that says now, right? That doesn't fully help us. We could try to break off the 67 if we wanted to, but what many of you all noticed is that there was another way to get the 8. But let's just say we have that 8, okay? We already know we have $8. The rest of it is gonna have to be used for the coins. Well, instead of me trying to come up with some way to get rid of the 8, which is definitely possible, right? I can remove the 8 in a couple of different ways that we've seen in part so far, right? And I could subtract off whatever that um, amount is. I could use a floor if I wanted to. Let's see, import math. I could use the floor function. I actually just be straight up to use them to see 7. And I gotta use math.floor. Okay. 700. Now I got 8 that way. But I need to know, regardless, I need to know how much is left over. So I could just subtract these two that I got here, right? Do 867 minus the floor version of it, which I saw someone do. But think about this. This means that we're doing the same operation twice in order to get one thing, right? And it's not coming out very pretty either. So what else could we do? Well, we could use the modulus because that will give me the remainder, right? That's the purpose of a modulus. It gives the remainder from a division problem. So if I just take 867 mod 100, it gives me the remainder automatically. It tells me that there will be 67 left over. In this case, 67 pennies. And then I can move on from there. So now I can do the quarters because I have 67, right? And again, I could use any type of division I want. We mentioned integer division as well, which was 2 of these slashes. And quarters are worth 25 cents or 25 pennies. If I do that, it straight up gives me that there's 2 of them. And now if I use the remainder or modulus to find that remainder, it'll automatically give me that 17. And so that's what you could have done in order to get that for the pennies program. That's what you could have done in order to make that a little simpler for yourself using the modulus. It was not necessary. I saw people subtract stuff off and it worked fine. So again, it was not, you didn't have to do it that way. It was just a way to make things a little easier for you all. So do you have any questions about the modulus? Okay. All right, no problem. Yeah, and the method that you use, of course, was perfectly fine. I mean, that's pretty much what a modulus does. So yeah. All right, so let's move on then to the conditional statement. So the conditional statement is based off, you do something based off a condition. So what does that mean? Well, how many of you, if I told you, if it's raining outside, I'm going to use an umbrella, you'd be like, yeah, that makes logical sense, right? And if you saw me with an umbrella, you might conclude that it's possibly raining. It doesn't mean it is though, right? But if it was raining, you definitely would know that I would have an umbrella. Well, that's a conditional statement. If it's raining, then I'll use an umbrella. That if then is that conditional statement. So we use these in sentences all throughout our whole lives. It's probably taught in English. I know when I took some English classes growing up, it would be taught to us then as well. And they have different names for them, and it's all mathematical and logical for the different types of statements you can have. But within programming, we have a way to flow through a program based off of certain conditions. And so to do this, we use if, and we use else. I showed you guys that last week. And we also use this thing known as elif, which stands for else if. In most languages, you actually will type out else if, but they just shorten it into Python. And when I was in school, when we were doing Python, Python 2, you actually could type out else if you really wanted to, and there was no issue. So we're going to look at how to use these within the problem. So um, let's look at the temperature conversion that we had before in last week. So let's say from the user, we want to know how are we converting, or maybe we want to know the units for whatever they're giving us. And so I may ask them straight up. I may ask the user using the input function. Is are you giving me degree? Are you giving me C, would be Celsius, or F, which would be Fahrenheit? Uh, Fahrenheit. If I spell that wrong, let me know. I feel like I did. Uh, I may even tell them, please only enter in, oops, uh, please only enter C or F, just so I can make sure they only do C or F. Okay, and then that will be my unit. Then I get my degrees from. So I may do another input where I say, how many, I'll do it here, say how many, whatever the unit they gave me before. Degrees to convert. Okay, and I'm gonna just run this so that you guys can see how it works. And I'm gonna print out both of these things. I'm gonna print the unit and I'm gonna print the degrees. And this is again just so you can see how these are being used and how they are working. I need to save this. There, okay. This is testing 03. Okay, so it says, hey, are we converting Celsius or Fahrenheit? I can put put C here. That's how many degrees to convert. We'll do -40. And that's what it has, C and -40, okay? So it is actually storing those units. So I can get from the user, am I using Celsius or Fahrenheit? And then they're going to give me the number of degrees to convert, right? So, well, that's pretty cool. Well, what can I do with that now? Well, if I know that I have Celsius and I know how many degrees I have, I know how to convert it to Fahrenheit. Likewise, if I knew that I was supposed to do Fahrenheit, and I knew how many degrees I had, I could convert to Celsius, right? We have the formulas for that. Fahrenheit. So I did spell it wrong. Thank you. Boop, boop, boop. Fahrenheit. There we go. All right. So let's set this up then. How are we gonna set this up? Well, I probably should look it up too. So if what the unit gave me was equal to C, then I would have to do the conversion from, actually, I'll do this way. If the unit is C, then I will convert degrees from Celsius. I'm sorry, but is this what we? No, no, this is not something you should have known to do. This is me teaching to you. Yeah, I talked about it towards the end of last week. But I told you all if you want to look more into it, you could, and you could potentially use it in your assignment instead of having to create two separate files. I wasn't expecting anyone to do it. If you did, then that would have been cool. But I wanted to use it as the example today regardless, so that way you could see how it would have been easier instead of creating two different files. Um, so if unit is C, then I'll convert from Celsius to Fahrenheit. Otherwise, or I'll say else, and if the unit isn't C, what is the unit going to be then? That's right. It's going to be if. Yep. Else, uh, unit is F. Then I will convert degrees from Fahrenheit to Celsius. Right? So I'm talking my plan out because remember, we always want to understand what our problem is first, and then we plan it out before we code. And so I understand what it is I want to do. So now I'm going to show you guys how would you do that in code. Well, we can use in conditional statement. Oh, why are you going over there? Here it is. We use a conditional statement. So I'm going to say if, and I'm going to say if the unit is equal to, so how do we check for equality? We use the equal equals. So if it was equal to C, then, and in Python, what we'll do is after we write our if statement, we'll put a colon. We'll press enter and watch to see where the cursor goes. It tabs its way in. This is very important in Python because where those tabs are within these statements, that's how it knows it's a part of a new block of code. So for instance, because it's tabbed in here, it knows that everything that's been tabbed over underneath this F is a part of what to do if that statement is true. Okay. If it was if we had backspace back over, we're gonna run into an issue because it doesn't know what to do for the if statement anymore. This is how it knows. Okay. That becomes very, very important because there's gonna be times where we'll have multiple if statements within one another called nested conditionals. And there's other things we'll do that will be nested as well. It is very important to have these code blocks in the appropriate spots. So you can use tab, shift tab, sorry, you can use tab, backspace will get you back over there. Tab will make you tab in more. But if you press enter from the colon here, it'll automatically tab over because Python knows that, hey, this needs to be inside of this if statement. So it needs to be a new code block here. Okay. So, but what we could do from here is we could take the degrees and start doing conversions, right? So we could So let's see if it's C. F was equal to was it 1.8 times C plus 32, or plus, in this case, plus 2 times degrees plus 32. Don't ask me how I remembered that in my head. It's been I do math and been doing things like this for years. But if you want to, you can look that up. It'll probably say 9/5 or something, which is the same thing as 1.8. So I'm just gonna take that, and that's my F. I'm just gonna call it F. But if I really wanted to, I could go straight to printing out a statement, right? I could say print. I'm gonna do F for formatting, and I'm gonna tell it to print out converted degrees, where the unit was, to Fahrenheit. I can put an F afterwards. Well, let's just see how this works for right now. So what I did was I said if the unit was equal to C, so the unit they give us, they're gonna give us a C or an F. If it's equal to C, let's print it out. Oops, got my parentheses in there. So let's print out the conversion here. And because I'm using the F format, I can put within the squiggly brackets the equation directly, and it'll still handle it for me. Okay. So I'm gonna run that. Okay. And so we're doing C. It says how many C degrees to convert. Let's do the 100 degrees. 100 degrees Celsius should be 212 degrees Fahrenheit, right, for boiling water. And I got an issue. Ooh, it says can't multiply sequence by non-int type. What do I do? Why is it saying this? Non-int type. I can't multiply, it says, the 1.8 times degrees because it's a non-int type. Well, that doesn't make sense, right? I just even enter 100. Anyone have any reasons why this is saying that I'm multiplying by a non-int type for my degrees here? Anyone got any ideas why it could be saying that? Cast degrees, yep. I didn't cast this to an integer value. So in this case, does it really matter if I do float or integer? It doesn't. It's probably actually better to do float just because I'm multiplying times 1.8. And in case I want like decimals in the degrees, right? So this would work perfectly fine. So I'm gonna float it. And then this unit up here, it's fine for it to be a string still, right? Because remember when you do input, it comes in as a string. This case, it's fine for it to be a string because we're talking about C or F. Okay, so now that we got that settled, let's run it and let's see what happens. You just see again, I'm gonna do 100, and it says convert 100 degrees and that, or 100 Celsius to 212 Fahrenheit, and that probably would be understandable for someone to be like, okay, I understand what it did there. So yeah, that works fine. I'm gonna run it again. What happens when I do F and I tell it to convert to 212? It should give me 100 now, right? Well, oh, I haven't coded that yet. So even though you have one thing done, it doesn't mean it automatically has the other. Now, at this point, I have seen people do this too. They will do an if, and then they would do another if, because we could check again to see if the unit is F, right? Because in this case, when it goes here, it says F unit is C. We'll say unit was F. It would say, does F equal C? Well, no, it doesn't. So it would not run this block of code. It would just go to the next thing. It would just say, okay, I'm out of this if statement. I'm gonna go to the next thing. So it's possible for us to do F unit equals F again, but because we would expect the user to only give us a C or an F, because the user only give us a C or F, what could we do here instead? We can say else, because we expect that to automatically occur. All right, it should automatically be in Fahrenheit then. So we could then go to print, do our F. I'll say converted this time. Degrees. I'm getting different outputs. Did you put within the squiggly brackets, or you may have formatted a different way, but when you calculated the Fahrenheit, did you do 1.8 times the number of degrees plus 32? Yes. Okay. Could you do me a favor and copy and paste the code that you have into the chat? And we'll take a look there. See if we can help. And you can send it to everybody if you want. Print 32F. Yeah, okay, so your stuff looks exactly like mine, and you did the degrees as a float, right? When you cast it. Yes. All right. Well, let's see. And you entered in 100 in the last example when you ran it. Okay, good. Yeah. Hmm. What did it give you as a result? Oh, so it did not give you a result? Okay. Did you had you run from the new file yet? Did you save and run the new file with the new stuff with the if statement and everything? Because that would be the only reason it wouldn't give you a result, because it's not going to this line. Yeah, try again. Let's want to make sure that that gets taken care of. So for this one, you guys could look it up or go back look at the homework. That's 5. Same result, same thing, not getting anything, or same result as it's working now. Not getting any calculation. Okay. Well, we're gonna see what's going on there. Well, I mean, we're on this part right now. No issue there. Okay. And let me see. I'm gonna look at your stuff at the top here. Using Fahrenheit, how many? You closed the parentheses off. Yes, you did. And you have an if statement just like this, right? Oh, sorry. Just like this one here. If unit equals C. You got the degrees part there. F unit equals capital C. Yes. And then all your other stuff looks right. Oh. Okay. So I'm going to test this out real quick. So I'm going to do capital F here, 212. And we're getting our stuff to convert fine. So I'm actually going to pass the ball to you, Tyler, if that's okay, because I want so you can share your screen. Is that okay to do? So we can take a look to see what possibly could have gone wrong. Is that okay? Yes. All right. So I'm going to pass the ball to you. Okay. All right, so you're now the presenter, Tyler. So you can share us your Python screen and we can take a look to see what's going on.
Can you walk me through how to share?
Oh yes, sorry about that. So at the on your WebEx screen.
Okay.
Yeah.
Sorry. Idle.
Yeah, you can share.
All right. So can you see all that now?
Yes, we can. Okay. Okay, cool.
I'm gonna mute myself again.
All right. So he restarted stuff and it's closing out after he gets his degrees in unit. Unit is spelled the same. Anyone feel free to shout out too if you see any possible issues. Everything looks good there. Oh, well, now that's working, which just converting.
Yeah, of course it works. I don't know what I didn't change anything though. I just
Well,
added this here.
Yeah. Well, that's okay. So, it still did not operate correctly though. See, and it's skipping your if statement. It went straight to your else. If you notice that, it went to.
Should I maybe?
Let's see, all your things there are fine. Your print's okay. So this is what I do. At this point, we don't see a error pop up, but we know there's a bug, right? There's an issue. And so what I would do is I would above your if statement do a print for a unit and a print for degrees, so we can see what's happening right before it goes through the conditional statement. So here's a good debugging way to debug if you ever run into issues, especially with if else statements, and when we get into loops today as well. You can kind of see what does my variables look like before we get to the next point. Okay. All right. It says C. Do you? Okay. I see. Do you look at when you type C? Do you put a space? So like run your guy again.
Oh my God! Yeah, dude. When I supposed to?
Yeah. Because if you put the space, it's checking to see if unit is equal to C, and unit is not equal to C. Is equal to space C at that point. So give that a try. There we go. There we go. But I was gonna get to that a little later, but I wasn't thinking about that possible issue. But I was thinking about if people were to enter in a different letter, or if they entered it in lowercase, what would you do differently? So thank you for that. I'm gonna take back control, but everyone take heed to that though. The issue was just what was being entered. It was a user error, which happens a lot. And so sometimes when you're coding things, for instance, like what we're doing here, and that's a perfect segue to literally what I was just about to do. If someone, for instance, were to do this, they may type a space afterwards, kind of like what Tyler did, or they may have typed lowercase letters. Well, how do you prevent that? How do you make sure that it is a C or an F before you move forward? Well, it's very simple. You can check it. Well, how are you going to check it? Well, based off another condition. So I could do another if statement above this to make sure. There's some other things I can do as well. So one thing that I like to do is I try to either make it all uppercase or make it all lowercase. And we'll see this more in the future. But at the end of this, I'm going to put a dot lower. And what that does is it'll make it lowercase automatically. I could do upper, dot upper as well, which makes it automatically uppercase, but it doesn't really matter. Actually, I probably should do dot upper because I already did it capital C and capital F, and I don't want to go back and change all of that. So dot lower or dot upper. Lower would mean it'll be a lowercase. Upper would mean it'll take the string and make it uppercase. Okay. So whatever they enter in, notice I have these two parentheses behind it. So dot upper, or you could do dot lower, open and close parentheses. And what this is a special method for strings. Anytime you see these dots and then a function following, kind of like when we did the math dot floor, math dot ceiling, math dot square root, those were special methods coming from the math module. This is coming from is used on strings. So it comes from a special string module, which all strings are part of the string module because they're all string objects, which we'll talk about much later. But each object has special methods with it. So upper and lower are those instances. So what this is going to do is it's going to make sure that it's uppercase or lowercase. And so what I could do here is I could check to see if what they entered is a C or an F before I move forward. So I could say F unit equals C or unit equals F. And then these guys all have to be indented in because they're a part of this new code block. Before anything starts, I'm saying, is it a C or an F? Because if it's not, I don't want it to run. I don't want it to run this code. Now, there's actually another way to do this, but before we do that, I'm gonna give it an else statement to go with this, because if it isn't C or F, else if it is not C or F, what I'm gonna tell them to do is I'm gonna print you did not enter a C or F. Please run again and follow instructions. That's all I would do. And then so now I run this. Oops. There's a missing parent somewhere. So if you guys saw the error, it said end of EOF, which we talked about last time, it's end of function. So there's a missing parentheses right here. I love getting bugs because it helps you guys see different things, different ways to fix them. So in this case here, if I were to type D, saying D degrees, so I can type in a number here. You did not enter C or F. Please run again. Follow instructions. Right. And that also, I could actually put that if statement higher up. So before you even get to the degrees, you could do a check there if you wanted to, which would then ask them the same question again. So there are a couple of ways to do that. I'm going to run it again though, so you guys can, that's what the instruction says. It says, please run again and follow instructions. So this time I'm going to follow instructions, but I'm going to put a lowercase letter. I'm going to put C. I'm going to put -40 in here. And it converted it. Last week, what was the conversion that stayed the same? It's -40 degrees. -40 degrees Celsius is the same in Fahrenheit. But as you notice now, even though I put it lowercase, that dot upper at the end of that is automatically going to make it uppercase, so that's going to run fine. If more people were to like press space before they enter letters, which happens all the time, there's another string function that will help get rid of that. It's called a strip. And so if I really wanted to, what I also could do is a dot strip at the end of it too. And so this will make it uppercase. And what strip does, it looks at the first thing and the last thing and gets rid of any white space that may be there. So in case someone even entered in a letter and then press space afterwards before they press enter, which happens a lot, this would get rid of that extra space so we wouldn't have to worry about it. These are two ways that help that help kind of to prepare for possible user errors. But most of the time, what you do is you do another if statement to say, hey, to check, did they enter in what they were supposed to? And if they didn't, you just ask them the same input again. But I'm going to save this and run it so you can see. I'm going to put spaces on purpose. I'm going to do a space and then F. And then it's asking me what to convert. I'm going to do 32 this time. I get 0. So even that space was there. That strip got rid of it. We're running again. This time I'll do a C. And I would do 273 degrees. So I put a space after it. And what happened here? Okay. So that strip is getting rid of it. I said there was another way to do this. So I want to show you the other way as well. Because this is newer. It's been around for a while, but it's been used more. It's being used more commonly now. Get rid of. I guess I want to get rid of all that because I'm about to copy that to somewhere else. So the other way is known as an assert. And so what assert does is it checks. It's a way to check to make sure things are working. So if it'll check it, and if it's not working, it just won't. It'll give the user an error that you specify. Or if you don't specify anything, it just won't continue running because it's just like, no, you messed up. So what I could do here with the insert, and I guess I shouldn't have deleted all that because I could have copied and pasted it a lot easier. But I can check to see at this point, does unit equal C, or does unit equal F? And if not, comma, then what I'm going to do is, this is what I want you to do. I'm going to cut that. I'm going to paste that up here. You guys a little more room with that so you can see it. Okay. So I'm going to run that now. And I'll put D in here. Okay. And say assertion error. Hey, print that stuff out. Oh. Yeah, I guess I don't have to put print in this version. Sweet. Let's see if that's going to work now. There we go. D. Yeah. Okay, cool. Assertion error. You did not enter a C or F. Please run again and follow instructions. So now I'm telling the user, here's the error. It's not a coding error. It's an error on the user because I am asserting to them you didn't do something right. Okay. So that's another way to do that besides using another if statement. Now, be perfectly honest with you, depending on what type of person is the user, the first way that I showed you guys using the if statements is probably going to be better. Because unless the user is a programmer, they look at all this red, they may say, whoever programmed this didn't do something right, when we're clearly saying it's the user's fault, right? But if it is going to be used by other programmers, they look at this and they may say, oh, something's wrong with the code they wrote, but they can look here and like, oh no, I messed up. Maybe remove the space between this guy here. Just so it to be easier to read. I don't have to type in there. Okay, good. Is that easier to read now? Wow. Okay. Yeah. Okay. Good. Good. So, and I like that too. So he was just to let us know, like, it'd be easier to read it if it's with the space there. So you can do that too to make things look as best as possible. All right. So that is the assertion. That's actually not even something that we have to actually, like, you have to learn in this class. I just think it's very powerful to use, especially when you guys are programming, because I use that myself when I'm programming to kind of test stuff. Because let's say I messed up somehow with this stuff up here, this will allow me to see what's happening between the C and Fs. Okay, so that it can continue, so it'll break and then it'll give me an error. Be like, Christopher, you messed up here. Sometimes I'll do that to even test stuff as well. Like I may put the assert above this print for some reason. Like if the degrees and units weren't integers, like how I did earlier, I can check that before I actually run it. So, but anyway, so that is conditional statements with if, else. Now let's say instead of just doing Celsius and Fahrenheit, we started adding in Kelvin as well. So I'm gonna get another OR here. I'm gonna put OR K, and I'll be Kelvin. Okay. So now I have three options. So I'm checking for C or F. I have a third option. Well, I want to see if it is Kelvin. I want to tell the user don't use Kelvin. So what I'm going to do is I'm going to give it instead of creating a new conditional statement, I'm going to add an else if here. So else if. So else if the unit is K, colon still, press enter. Notice again it enters into a new code block by indenting, or you can think of it as using tab. What am I going to tell the user? Do not use Kelvin. Kelvin is actually a really powerful tool. I'm just making fun of it. So I'm just gonna tell them, please do not use Kelvin. And then maybe I'll say you have, and then leave it the same, degrees. Okay. Did I forget? Oh. Set invalid syntax. Notice even highlighted here. What's the issue here? I'm checking to see if unit is the same as K. What's the problem? I'm just checking to see if you guys are here with me, but I know you guys got it. K define. K will be. It's just going to be a string that's given in. The issue is when I'm checking to see if something is equals, I need two equal signs. Equal, equal. Equal, equal. Okay. If I have one equal, I am trying to assign it. And that's not what we want to do here. We're trying to check to see if it is K. So now what I'm going to do is input K. How many K units convert? 273. And oh, I still have that assertion in, so it didn't even continue moving forward. Get rid of that guy for right now. Run it again. Now I'm gonna do my K. Sorry, I got trigger happy that time. There we go. K, 273. Do not use Kelvin. You have degrees Kelvin. Oh, it didn't print out the degrees. I wonder why. Well, if we go back here, I'm using the squiggly brackets, but it still didn't print it out. How did it not know to print out the degrees? It worked on all the other ones. Well, if I look at the other ones, notice that I have an F in front because you need that F there in order for it to format in that way. And I did not make that mistake on purpose. That was an actual genuine mistake I made. So I am not perfect, and that is okay. But it helps you all see too how to go back and look at if you make a mistake, how do you go back and fix it? How do you go figure out where the mistake is? So in that case, I went back, I noticed it gave us degrees. That wouldn't make sense because it worked for everywhere else. Well, what's the issue? I can go back and compare, or I can remember that in order to use the squiggly brackets for it to interpolate, and there must be an F to format it out front. All right. Any questions about F, LF, and else? No? Okay, cool. Cool. So, what we're gonna look at now is like, this is very helpful, right? Because you want to test to see if something is a certain way before you move forward, or based off what's given to you, you may do different things. I think I showed you guys last week, I was trying to do to see if something was even or odd, and I was taking stuff from the user. So like we took a number, and we made it an integer. We did an input, enter an integer value. And then if we took that number, if it was mod 2, we got a 0, what would that mean? Well, if we do a modulus with 2, that means we're looking at remainders. And so I'm saying if the remainder, when you divide by 2, is 0, then what does that mean? Well, that means the number can be divided by 2. If the number can be divided by 2, that means it's also known as an even number. So maybe I would print something out like F, and then put the number is even. Else, if it didn't work, I could say that the number is odd. Okay. Oh, forgot my parentheses. Come on. There it is. Okay. So I'm still going through that stuff. Probably actually should have commented it out. Enter an integer value. So if I put 3 in here, it says 3 is odd. So I could use that in order to see if something was divisible by 2, if the number was divisible by 2 or not, and tell the user that a number they give me is even or odd. So it's a cool way to use conditionals. So, but I wanted to show that example too, because that's the one we were ended on last week. But I wanted to show you because in this case we're testing strings, right, to see if they're equivalent. In this instance here, we're doing a calculation before we test it, and you still using that within a conditional. So all of these work, and these can be very helpful too. Think back to your very, very, very first assignment when we were doing the workflow demo. Okay, and I'm gonna just open that up here quick. Back to it. And some of you may have been you were just to type the code, right? You didn't have to come up with the answer on your own or anything, right? It's still there. And the process he walked through, it probably made a lot of sense to some of you. I know many of you can't see this as well, or can't hear it, so I'm not gonna play it. But I do want you to see. Let me get a little bit more here. There we go. See colors. What have we gone through so far in this class? Well, we've talked about assigning variables, We know about greater than or less than. We've used input. We've casted it to ints. Have we done a not equals? You've seen it, right? We can do 2 equals for a test for equality. Not equal, the test to see if stuff is not equal. Greater than or less than, greater than or equal to, less than or equal to. We've used Booleans. We've casted the strings. We've done concatenation by putting strings together. We've done everything in here except for these 2 things, this for and this while. And that's what we're going to talk about now. So think about this assignment what you did here. So the user would enter in a number, right? And when they enter in a number, it would check to see, it would check for its prime factors, and it would just multiply, or it would print out to you the multiplication of all the prime factors. So that was pretty cool, but the way that it did it, you may not have realized what it was doing was it took the number and then it did something to it, and then it took that result and did something else, and it took that result and did something else, and it kept doing it until it got done. So it had to be a way for it to know when it was done. Well, we're gonna do something similar to that, because sometimes you want to keep repeating something over and over again. For instance, when you guys were doing the pennies and dollars thing, right? I said that there was another way. There were lots of different ways to do this, and I mentioned not in the assignment to not do anything with loops or anything like that. This is what I'm talking about right now, because I wanted you to do it just the other way, because loops were unnecessary. But you could have used loops in order to do it. So I want to talk about that. But I think a better way to start with that is talk about, let's say, division. Let's say that you had to, or multiplication, doesn't really matter. I'm going to use division though, because I think it'll make more sense this way. Let's just say you wanted to divide 2 numbers. Doesn't matter what the 2 numbers are, but we want to divide evenly. So let's just pick something like 243, and we're going to divide by 3. Okay, so we're going to do 243 divided by 3. And so yes, in Python, we know that we could just type this in, right? 243 divided by 3. We get 81. We're good. We're done. But imagine that for some reason division didn't work here. It just broke. So the only thing that could be done, and let's say multiplication broke too. The only thing that could be done was addition or subtraction. How would you tell the computer to divide? So I want you guys to think about that for a moment. If we had 243 divided by 3, and you had no way to do this, where the computer would do it for you, calculator won't work, none of that, how would you tell the computer to do it? You can only use addition or subtraction. What would you all do? Think about that. How would you get to 81? And if you want, start smaller. Start with like 6 divided by 2. How would you know that that is going to give you 3? Repeated subtraction. Yes, repeated subtraction would work, because that's what division really is, right? It's just repeated subtraction, just like multiplication is repeated addition. So somehow we need to tell it to repeat subtraction. Well, what are we gonna, so let's go back to, let's do a smaller example first. So the 6 divided by 2 example. So how would you get your result? You say repeated subtraction. Well, what are you subtracting? Yeah, you're subtracting 6 by 2. That's right. So let's kind of walk through that process. So we want to see what the result is. So we're going to do 6 minus 2. We're going to take that minus 2. We're going to take that minus 2. We're going to take that, We're going to take that minus 2. We're going to take that minus 2. We're going to take that minus 2. I hope someone stops me. We're going to take that minus 2. We're going to take that minus 2. You guys see, there's only one issue with just saying repeated subtraction, but it's not even an issue. What you said is correct. We are doing repeated subtraction. But there's an issue with just doing just that. There's something else I need to do, right? Until I reach 0. Yeah, so until I reach 0. So kind of plan this out a little bit. So we're going to use what's known as a while loop to do this. But just kind of talking it out, I need to take my dividend and repeatedly subtract the divisor until I reach 0. Okay, until I reach 0. Okay, so once I reach 0, how do I know what the answer is? All right, so if I said 6 minus 2, 4 minus 2, 2 minus 2, I get 0. How do I know what the answer is though to this division problem? You guys know the result should be 3, but how are you getting 3? Based off the fact you're just subtracting by 2. And you stop when you reach 0. How would you get 3? Counting the number of times you subtract the value. Exactly. And so this is why I like using this in multiplication example with the loops. Yes, the number of times you loop it. And so there's a way to do this within a while loop. And I think that's why I love using this example to illustrate a while loop, because this is exactly what you want to do with a while loop. You want to have some kind of count so you can see how many times you're going through the loop. And sometimes it's not just how many times you're going through the loop. It may come up to a different type of number, but you still have some type of count involved. You continue to do something over and over again repeatedly. This is known as an iterative statement. Iterative meaning that you're iterating through something. So you just continue doing something. The last thing is you also need to know when to stop, because otherwise it'll keep going on and on forever, right? So in other words, we need to terminate this loop at some point. So when I was in school, this is copyrighted by Cal Tate and Kathleen Keller. They ever watched this video anywhere? They had this little jingle for us. It said, "Step 1, set the base case first. Step 2, call it again. Step 3, you got to terminate. Otherwise, you get an infinite loop." So that's what we need to do. We have to set a base case. So letting it know what it is that we're doing. In this case, we can think of that as our count. Then what we need to do is set it up so that it repeats itself. The last thing is that it will terminate. It's going to have to stop somehow. So we have to have a way to check that. So that's what we're going to do here. And so I'm going to first start off by setting our base. Like we said, there's going to be some type of count. That's our quotient. So I'm going to treat here, and I'm going to say the quotient. And we're going to just say, you said it was going to be the number of loops, Renee. So I'm going to say that we're starting off with 0 because we have 0 loops to start off with, right? That makes sense. So I am now going to use a while loop. And with the while loop, you want to test some type of condition so it knows to continue. And you guys told me when to, for how long it need to continue. It need to continue until something reached 0. And that was going to be the divisor, sorry, not the divisor, until we reach 0 here. My computer says, yes, I will post this on Canvas. Yep. And I'll send a link by email as well. So, enjoy the nuggets. So while the dividend is still not 0, in our case, that's what we said. We want it to keep going until it's not 0. You're welcome. I probably should save those somehow. So let's call it what it is. So right now we have 6, and then we're gonna change the divisor to 2, and I did not name, that's correctly, dividend. There we go. So while the dividend is still greater than 0, there's my condition. So I'm checking to see is the dividend greater than 0. In this case, it's still 6, right? And what I want to do now is I want to divide, but you guys told me that's repeated subtraction. And you told me I was subtracting the 6 from the 2. In this case, that would be the dividend minus the divisor. And I would save that to the new dividend because that's what I'm going to use to subtract the next time, right? So we look back here, we had, here, 6 minus 2 is 4. Then we took that result and then we subtracted 2 again. We took that result and subtracted 2 again until we got to 0. So I'm going to take my dividend and set it equal to what I get when I take the dividend minus the divisor. You may recall for the last 2 weeks, we talked about this. Whenever you're doing something, repeat it to what's being assigned to the same thing. There's another way to write this. So again, whenever you're assigning something back to itself after you make a change, there's a different way to do this. You can use what's known as a compound operator. But the compound operator is saying dividend is going to be equal to whatever you get when you take dividend minus divisor. And every time we do that, you all said we needed to increase the count, or we need to check the number of loops. So I'm going to take the quotient and I'm going to add to it the number 1 because that's just going to count how many times we've gone through this process. Okay. And so while the dividend is greater than 0, we're just going to keep doing this. Right? So I am going to check to see how well this goes. I want to skip over some of the other things that we did for now because I don't want to have to keep running through those. Okay, I'm gonna let this guy go now. So let's go here. Okay. Oh, nothing happened. That's only because I didn't tell it what to do after it got done. So I'm gonna tell it to print, and I'm gonna get fancy with it. I'm gonna get fancy with it just so we can have some nice things there. I'm gonna put the dividend, put divided by the divisor. Is, and then whatever the quotient is. Okay. Forget that guy. Oh, it said 0 divided by 2 is 3. Well, I did tell it to do dividend divided by divisor's quotient, so it gave me the right thing. But why did it not give me the correct dividend? Anyone got any ideas? It did not give me the correct dividend. Any ideas on what else I can do to make it give me the correct dividend here? This is working, right? Obviously it is. We got 3, so it's working correctly. Okay. Well, this guy is looping through and it's taking the dividend, it's changing the dividend each time. And so that's the issue of why I can't just use the dividend that was the result down here. So what I should do And there's other ways to do this too. But somehow I need to save what I'm starting out with. This is one way that you could do this. And so I'm going to do that just with a string here. Like I said, there are multiple ways to do this, but I'm gonna cheat a bit here, and I'm just gonna save this as a string. So I call it the original dividend score, and I could put 6. I could put the same thing I had before, dividend or whatever. It doesn't really matter, honestly. Other things you could have done was to save it as a string of that. Other things you could have done is change the term that's being used in here that's being reduced to something else, like the remainder, which I'm going to actually ask you guys to think about in a second as well. So I'm going to run this here and see what happens now. We get 6 divided by 2 is 3. Okay. And so now I have my own little personal divider. So I'm going to go in here and let's do it for 243 divided by 3. Just notice it took a little bit longer, not that bad though. It still was able to go through here. And so we just did division without actually using division, but only using loops. That's pretty cool, right? And if you wanted to make this a little fancier for the user, instead of them having to open up the program, enter in what the dividend and divisor is, you could just ask them, right? We could make these into ints of user inputs to get that. But there is a issue, right? Because right now this is only going to do integer division. If we wanted this to be able to do, say, leave it as a mixed number, or do division and give us a remainder, there's something else that we may want to do, right? We want to somehow save the remainder. So that's what I was talking about, maybe changing this here. So do you guys know how a remainder actually works? You take your dividend, divide by your divisor, and you end up with the remainder. Well, as you think about what we're doing here, if it kept subtracting, and now let's start with an example here. Do like 8 minus 3, or 8 minus 2, because, not, yeah, sorry. Because we did minus 2, so let's do 7 minus 2. Okay. So I did 7 minus 2, that would give me 5. I do 5 minus 2 now, that would give me 3. I do 3 minus 2 now, that would give me 1. And if I keep going, I'll never reach 0, which is what our while loop is saying right now. But this is where I'm supposed to stop. How do I know this is where I'm supposed to stop? You guys got any ideas? So ideas on how or why we know to stop there. Okay. Because you can't divide by 2 again. Right, we can't subtract by 2 again and it'll become negative. So that 2 is our divisor. Because we can't subtract that because it's no longer big enough. We can't subtract it because it's no longer big enough to subtract without going into negatives. So in our code, instead of putting 0 here, let's just say while it's greater than the divisor. Right? Because as long as your dividend that you're using still is greater than the divisor, you can keep going. And so with that, that means we have the remainder. It's going to be whatever's the dividend afterwards. Okay. All right. So let's play with this with some other numbers. So I'll do the 7 and the 2 because that's what we just use as the example here. So it says 7 divided by 2 is 3 with a remainder of 1. And if I wanted to get really crazy here, I could do 1024 divided by 125. And it says we get 8 with the remainder of 24. Okay. So as you can see, no matter what the problem was, in this case we wanted to create something that would do division for us. We're still able to do that. We still had to plan it out. We divided. We knew that we needed to divide. We needed to use repeated subtraction. You guys also told me that what would we be subtracting? We would be subtracting the dividend and the divisor. We would keep, you told me when to stop, we would keep going until we reach 0. But now we realize we can keep going until you reach less than the divisor. Because once you do, you can no longer subtract anything, otherwise it becomes negative. Right. And so within that planning, you were able to set up a while loop. A loop is going to be used anytime you're going to do the same thing, repeat it. And so we set our initial conditions here, but really the main thing was to set up something that's going to be used to count what you're doing. And you probably realize the point of that is so that you can have a condition here. Sometimes you're going to want to count down. Other times you'll want to count up. Like if we were to do a multiplication maybe now with this instead, if we were multiplying, we want to count up until we got to the second or first number, however we wanted to program it. Okay. But in this case, after you set up your condition here, you want to have whatever it is you're going to iterate, which you're going to continue to do over and over again within the while loop. But you also want to make sure that this is going to terminate at some point, and this is why we use that condition. Okay. I want to point out that notice how there's no if statements here. The while loop has a condition. It did not have to have an if and else up here in this line. The while loop has its own conditional. Do not do while if done, then while if done. Don't do that. It's just while this condition is true, keep doing this stuff. It'll stop when it's no longer true. Okay. All right, so that was an example of a while loop. Are there any questions about using a while loop? Okay. All right, so next thing I want to talk about is the special function that will give us a list of numbers. We'll talk about lists in about 2 weeks. Oh, can you explain why you use the F in printf? So I use the F just because it's remember that's the fastest way to format it, and I wanted to write a sentence out to let the user know what happened. So that allowed me to just use those squiggly brackets to automatically put in those variables, or put in the results from those variables. So that was the only reason. You could use dot format. You could use the format function as well, or use the replacement with the modulus, whatever you want, or just print out the result. Period. You could have just printed out here's the quotient with remainder. Okay. So I want to show you guys a special way to get some numbers, and it's a special function. It's known as range, and it's really cool because it gives you the range of numbers. So the arguments for the range function, as you can see here from the screen tip, are if you only have one argument, you're telling it where to stop. You can also do 2 arguments telling it where to start from and where to stop. Or you can do 3 arguments where you tell it to start, stop, and how to increase, what steps to increase by. So I want to show you that because we're going to use it in the next type of loop that we're going to look at because it's commonly used with it. So I'm going to do a range, and 9 is my favorite number, so I'm going to do 9. Let me show you what that does. Okay, all it says is range 0 to 9. Well, that doesn't really tell you much of anything, does it? Well, let's take a look at it this way. Hopefully it should come out here, 0,9. Is it not going to put it as a list? Let's see, a range. Nope, it's gonna put it out that way. Okay. So I want to show you what that actually is. So when you do a range, what it's actually doing is giving you a list of numbers. And it'll give you a list of numbers starting from where it said up to where you finished. So yeah, I'm gonna do it this way. Oh, and range 9. Are you mad at me? Yeah, it is. Okay. So I'll have to show you guys another way. But so what this does is it goes up to this number, so to 9. So range 9 will go from 0 to 8. So it'll go 0, 1, 2, 3, 4, 5, 6, 7, 8. It won't get to 9. If I were to put from 1 to 9, what it'll do is it'll do 1, 2, 3, 4, 5, 6, 7, 8. So it always starts wherever the first number is, if two numbers are given, and it'll stop right before that last number. And so I'm going to give you guys a couple examples here. And I'm going to upload the PY file like I usually do at the end. So range 9 would go to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or sorry, 8. And then let's see, range, and I'll just do a different number. Let's do 5, 9. What that does is it goes from 5, 6, 7, 8. If I were to do something like range, let's do 0, and let's go to 9. But I say by 2s, what's that going to do? It's going to count it by 2. So it's going to go 0, and then 2, and then 4, and then 6, and then 8. Okay. Still going up till it gets to 9, but it's going to count by whatever the number is that's given there. Okay. And you can also make it go backwards as well. So instead of counting by 2s, if I did something like this, 0, 9, I said -1, it would count backwards. So we would get 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. And so that's what the range function does. And the reason, again, that I wanted to show that to you is because it's very popularly used with the for loops, which is what we're going to look at next. So it's another type of loop here. So all right. Come on. All right. Apologies, my mouse is going a little crazy. So I'm gonna look at a for loop. So it's similar to a while loop, except with the while loop, we had to have a condition for it to know when to stop. So it continued going until it reached that condition. With the for loop, we can tell it exactly where to stop. So for instance, if I wanted to say for a number in the range of 9, print the number. I want you guys to see what's going to happen here. Let me do that. So for a number in range of 9, and num, I just put num, just generic. I could put anything I want here. But for every number in this range, print that number. So I said that this was from 0 to 9. Notice it starts at 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. If I use some of those other things that we looked at, like I had 5, 9 here, let's see what it does. Goes 5, 6, 7, 8. If I were to do the 9 that we mentioned here, 0 to 9, comma 2, should count by 2s, as you see here, 0, 2, 4, 6, 8. And if I were to do it -1, oh, that's not in it. And we want it to go backwards. Why we're not? Mm-hmm. Oh, so that's not working in the range function anymore. Okay. Well, I'll show you guys how to do it backwards then when we look at lists, because there is a way to do it backwards within the list. But for right now, this is how you would use a range. And the reason I am showing you this is because in your homework, go back to your homework assignment here, you will have to use a loop. Now you can use a for loop or a while loop. Notice the difference here, that with the while loop, you have no idea where to end necessarily. So you are using the condition to make it stop at some point. With the for loop, it's going to keep going until it has nothing else to do. So in this case, we're telling it to start at one point and end at another. So let's take a look at your homework for this week. Are there any questions about the for loop or the while loop? Nope. Okay, cool. All right. In that case, let's take a look, as I said, at your homework. Sorry, my mouse is going a little strangely here. Okay, there we go. All right. So get 3D salary schedule. So, and I would love for you guys to try the backwards one too on your IDLE, because I got it working on my other version online. So I'm gonna have to figure out why it's not working on this version. It ran through, but it didn't print anything out. So I want to see why that was when we did the backwards one. So, but looking at our homework here, and it may seem like a lot going on, but Acme Widgets Inc. values its loyal employees and strives to keep them long term. Salaried employees earn 2.75% cost of living increase on the current salary. So what that means is that they get 2.75 increase to their salary, plus a salary increase of 2,350 in base pay each year from their hiring date. So we're going to write a program that will take in an employee's name. They'll take their starting salary and the number of years they plan to work. So say they work 20 years, 10 years, 5 years. It should then show a salary schedule showing the adjustments discussed above. So there's a 2.75 increase plus a 2,350 increase in base pay. Okay. Notice also here that the 2.75% increase should happen before the 2,350 increase. So here's an example here, how much she started with, and then where she ended up at. And so I want you to write a program that's going to do this. Now, That is your homework assignment. And then at the end of it, we're going to put how much do you have in total over the years. Okay. So I personally would program this in a few steps. I would, do my description stuff because that's simple enough, right? You guys you've done that in 4 assignments now. So that's just a bunch of print statements. After that, we're taking user input. You guys know how to take in a name or take in a string, how to take in a integer value. Could be a float, right? If you want it to be. Just remember that this is dollars and cents because it has to do with salary. So 2 decimals is the max you can go there, but you guys still know how to do that. Number of years that you plan to work. This should be an integer value. It just makes sense. If you really wanted to, you could make it go to half years, but I would suggest just sticking to an integer and forcing it to be an integer because you only get the increase at the start at the anniversary of your original hiring date. So the rest of this stuff with the year 1 and then the thing here, I personally am not looking for all of that. That'll be nice if you want to fancy it up. But what I am looking for is it to print out each of the increases. This again will be easier to see it. This is all that's really necessary. I want to see this increase, and at the end, I do want to see the total here. So once you think about that, you're going to give the amount that you start with. You're going to give the number of years you're going to work. You can use a while loop or a for loop to do this. While loops, you go until you get to a certain point. We know what point we have to reach, 20, right? For loops, you go until you get to a certain point. In this case, we know the point we want to reach. The difference between those two is that sometimes with the you don't know how long it's going to have to go, like how many iterations it needs to do. So a while loop is nice because you don't have to tell it exactly how many iterations. You can give it a condition to test on to know when to stop. A for loop, you can't do that from the for loop line. There are ways to do it within the code to check like with the if statement, but it's kind of nasty. It's not good coding. So that would be the difference between the two. In this problem, it doesn't matter which one you use. Traditionally, if you know exactly how many times you need to loop through something, you use a for loop because it's easier on the code actually. It's easier on the computer to run it. So a for loop would be best for this. However, it does not have to be a for loop if you want to use a while loop. I know I have tutored some people in programming before. One person in particular that comes to mind, every time she did a loop, she always wanted to use a while loop. And I'd be like, okay. But it was the one she was most comfortable with because she could use that for anything. For loop you can't use for anything. Right? So I understood where she was coming from. But if you know exactly how many times you need to loop through, for loop is better on runtime. So for your assignment, let's just kind of think about how you could make this work. Right? So you get all this information in, and somehow you need to take the starting salary and for each number of years, you need to do a new calculation. It needs to increase by 2.75%. Oops. It needs to increase by 2.75%. And then on top of that, you need to add $2,350 to it, right? So I am going to do some stuff in idle and just describe that. So let's just say I made $40,000 to start off with. I want to increase that by 2.75%. You guys have any idea on how to increase that by 2.75%? Let's start there first. How would you increase by 2.75%? And there are multiple ways to do this. I just want to see what you guys think of. And if you weren't 100% sure of what a percent increase would look like, you could always Google search it, right? Maybe to get a formula. Let's come up with something here. How will we do a 2.75% increase? You guys have an idea? All right. Let's pretend we didn't know so you can see how to do a Google search. So if I want to do a percent increase, and to give you a hint, it's an increase. So usually when you increase something, you are adding to it in some kind of fashion. You repeatedly add something, it's multiplication. So those are ways you can think about how to do it. And it's a percent, so it's per each 100. So let's see. Calculate the percent increase. It says divide the increase by its original number and then multiply by 100%. Oh, that's trying to see what the actual increase is. So that's not exactly what we want. Maybe we look at this example here. Maybe this will help us. How do I add 5% to a number? It says divide the number you wish to add 5% to by 100, multiply this new number by 5, add the product of that multiplication to your original number. Enjoy working at 105%. Let's give us some steps to do so. Okay. So I could follow along with that. In this case, we're doing 2.75 though. So according to what we just looked at, we need to, let me go over here. According to what we just looked at, we need to divide the number by 100. So I'm going to take the 40,000 divided by 100. Then it says to multiply that new number by 5 and to add that to the original number. That was for the 5. In this case, we're doing 2.75. And there we go. So I got 41,100. Okay. So I will give you guys a simpler way in my mind. So I would take the 40,000. Anytime you do if you want to see what the increase is after you have a percent increase, what you can do is you can always multiply that number times 100% plus whatever the other percentage was. So in our case, 102.75%, because 100% is one whole, right? So that means that's the original amount, plus however much the 2.75 increase is going to be. If I do that, oh, sorry, this is a percent. So if I do that, that will give me, yeah, that will give me the same answer that we had before, 41,100. Okay, so either way, however you want to do it, you just take the number, multiply it times that percent, and add the original amount. That's what both of these are doing. Take the number, multiply it by the new percentage, and add the original amount. This way of doing it allows you to see that it allows you to do it in one computation, so to speak. So, and the 2.75 is already set in stone, so you don't have to worry about having to change it each time. And so that would be what we would get after 1 year. Then we'd have to take that result and multiply it by the same thing. If I want to get real fancy, I could do that by doing this. That's the same thing as doing 102.75 divided by 100. And that gives me my next increase. And I could keep going here. 1.0275. Get my next one, and I could keep going on from there. Now, in the project, you're asked to ask the user how many years they plan to work, and to use that to do this calculation. So, how would you do that? Using the loops, maybe within a loop. That's what you want to think about. Okay, so I kind of want to help you guys get started with this without giving away too much. So I think I talked about at least the formula portion of it. But remember, you're not just supposed to do the 2.75 increase. You're supposed to add the 2,350 after that as well. So keep that in mind as well when you're walking through this. But don't forget, these are going to be variables. And if you know the set amount of time you can go through this, you can just do a range up to that, right? So like, for instance, if I wanted to go through 20 times, let's just say, for instance, I had this num, and for each time what I wanted to do was to do the same thing over and over again. So let's say I wanted to add 1 every single time. So I'm going to run this just so you guys can see what happens. So I'm going to do it 20 times. So I started at the first one, then I added 2, then 3, 4, 5, 6, 7, 8, 9. So as you can see, I took whatever number that I'm on, and I just added 1 to it each time. Okay. Let's see. So there are a ton of different ways to do this. Say if I had a variable like a salary that was $40,000. Every time I come through here, I could take that salary. Oops. Let me do this one. I could take that salary and add to it. Let's say I got a 20. I used to get my other job. We used to get increases based off monthly pay. So let's say I got a 2,400 increase every month. Sorry, every year. Well, then I could print my new salary. Let's see what happens after 20 years. Oops, I added too much. I'm going to add the 2,400 each time. Sorry, I was adding too much money in there. All right, so I started off at 40,000. Now I'm at 42,400. Notice each time it's going up by the 2,400 over that 20-year span. Okay. That was pretty good, right? So I hope that gives you guys some ways to start off with your homework assignment. That's with the for loop. You could do it with the while loop as well, like I said. You don't have to do a for loop. The for loop is just better because you know exactly how many times you're going to iterate through it. Yeah, so I went over kind of the equations that you will have to use. Don't forget you have to do both parts. You have to increase it by the 2.75% and also add in the $2,350 as well. Don't want you to forget that. And I believe that will be everything. I guess there is something else. Think about how you would keep the total too as you move through that. So is there some way that you could save a total? You know, we have saved values before many different ways. Maybe if you start off with 0 here, and each time you just add that amount to what you had previously. That could probably help. Okay. Notice how those compound operators keep coming up each week? They're very powerful. So, okay. So, are there any questions with this at all? No? All right. Okay, I'm going to move on to the next assignment. So there's a video here to kind of go over what the assignment is about. But it's just concatenating. So just to get some more practice with it. This is probably going to be your most powerful, well, yeah, it would be your most powerful tool. Remember, the first student learning outcome is to take inputs from the user and also format outputs. Well, how you format outputs generally is using sentence concatenation. So those different formats we talked about, the interpolation, like the one I showed you before, but there may be times where you need to concatenate things based off of previous lines. So take a look at this guy here. I don't know if any of you guys have seen Mad Libs before. There used to be a TV show with kids. I think they had an adult version too, where you had to pick a pick an article. Where are you saving the py file? You mean like for you all to see it? I'm gonna put it on Canvas. I usually so back here real quick. So what I do for the py files in the videos is I try to put the py file at the end of what we've gone over. So I'll put this py file um, here to the end of it, and I'll put the video at the beginning up here. Okay. Yeah, those be those examples. So yeah, so the MATLAB thing. So you would take in different words based off of categories. Like I said, give me a noun, give me an adjective, give me a verb, um, and then these would go here, and then it would create funny sentences. So there would be ways to even generate this. People used to use computer games to just make funny jokes, and they would laugh at it. You know, if you see the purple dolphin jump thoughtfully onto a polka dotted violin, you'd be like, "What?" You know, or someone may get a laugh out of it. Usually, younger kids laugh more at it, but that's what a MATLAB is. And they're kind of cool. So it's just a little program to do that because it also makes it makes it easier for you to have some practice with concatenating. So just talk real quick about concatenation again. That's when we combine sentences together. So there's two ways to do uh, concatenation. So within print, if I were to put, say, a string, like first string, I could put commas and do second string. And when I do so, that comma lets it know it needs to put a space in between these two things. So I get first string, second string. The other thing that I can do, first string, is use a plus sign. When I do that, it concatenates it together without any spaces because there's nothing within the quotes of the string to tell it to put spaces. So it just brings the whole thing together. Now, a lot of times people will do that. They'll put a comma because they see it works within print. Notice here, that's not what happened. This actually created something different. It's called a tuple, which we'll talk about in about 2 weeks, maybe even next week. I may talk about it then. But we created a tuple here, which has its own different properties. So a comma only works to add the space within print. Okay. Do not just put a comma and think that it's going to automatically add the space. Most people will use the plus sign and add the spaces themselves within it. For instance, they will either add the space here or they would do it this way. So literally adding a blank space in between just to make sure. Okay. That's string concatenation. I honestly think that this assignment would probably take maybe like 10 minutes because of all the things you'll want it to type up and type out. Or like where it prompts the user, like the description and what it prompts the user. The rest of the code, like this here, making a sentence, you could put all of that in one line of code. I do not expect everyone to do that, but you can. Totally available. You could actually do that without even. Yeah, technically you could do that without. You could technically do that with um, nothing after that. There's a way to do this without having anything being calculated after you enter the last thing. And I just kind of want to see what you guys do, so I don't want to give that away. So next week I'll show you the fastest solution to this. Hopefully you guys remind me just in case I forget. But yeah, okay. So that's everything for this week. Is there anything anything else you guys want to, any questions you have for anything that we've gone through? at the moment. Anything at all, we can keep going all day, or I can. We have about 22 minutes left, although technically, this is not an official class date because we're not supposed to have class technically. But besides the point, are there any questions anyone has about anything we've gone over? I can do plenty of examples, pull some out of nowhere if we need to as well. No? Okay. Well, the next thing I was going to talk about in class would have been using nested if statements. But we've actually already covered that too. That's when you have an if statement inside of another if statement. We've already covered that. And then talking about nested for loops. So we had multiple for loops. So a for loop within itself, which we have not done yet, but I do want to show that. So I'm gonna show that as an example here. So what's there? This was for loops. So for loop. So with the for loop, you just say for some variable in some list, and then you tell it what to do. So then you put your iterative statement. Okay. And that's it. And it'll go through that until it gets done. There is a way actually to get out of a for loop. I guess I should say that. So if you wanted to, for instance, do like a, if you put an if statement in here, so if num is, if num is say 6, just so I can show you guys something else. You can do this thing as pass, and I'm gonna show you what this does. So look up here real quick. So that was on the first one. So that was 0, 1, 2, 3, 4, 5, 6. Okay, let's go down here. So what pass does is it passes that mark. So it won't do it, it won't execute anything else. So if I did if num6 pass, and then let's say I did else do all this other stuff. Yeah, we're gonna skip over it. Something else you can do is a break. What that does is it says, hey, stop as soon as you get to this point. So when it meets this condition, it breaks there. For instance, within this guy, let's say there was a salary cap that no one could make over, say, $60,000 or something. Then what we could do is put a cap. So if the salary equal or it was greater than or equal to 60, break, and it would be like, hey, I'm done. You can't finish anymore. Let's see. Yeah, I just want to show you guys that example there. All right, and then let's look at a nested for loop. And so that is just a loop within itself. So let's just say I said for x in range, I'll just do 0 to 10. Or in this case, I could just put 11 if I want to go 0 to 10. And then say for y in range, let's do the same thing, going from 0 to 10. So I'm going to put 11. I'm going to print x, comma y. And I'm going to put it in parentheses. 2. I'm gonna put this in the side of comments so we don't, running that multiple times. So notice what it did here. For x in range from 0 to 10. So for every one of these, so we start off with, say, 0, right? Makes sense. For y from 0 to 10, we're going to print whatever x is, which in the first case is 0, and we're going to print y, which would also start off as 0. Then it will go back up to this loop, and then say y is now 1. And it will go back up to this loop. Y is 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it goes back up here. Now x is 1, and y is 0. So 1, 0, and y is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it keeps going back. And so that's how a nested loop works. Very powerful when you're doing things, especially like if you're looking at like columns and rows. If you're doing something with points like x, y, like I did here. And you can see how the first part stays the same, and then the next part is iterating until it gets done. When it reaches the end of what's set here, then it goes back up to the previous loop and it goes to the next position, and then it keeps going there. Okay. And that's what a nested loop is. So again, another very powerful tool with for loops. So one other thing that I want to show you all, which I'm gonna try to make idle do this for me. For CN. Let's see if this is gonna work here. Did I break it? I did break it. Okay. Yeah, I want it to work in here, so I have to do it the other way. All right, so I'm gonna show you guys something else that you can do here. And what I want to show you was that remember I talked about range. I said that a range was will give us a list of numbers, start with the start and end, and that's why it was very powerful with the for loop. Well, a string is just a list of letters. That's all it is. So it's already a string. It's already a list. So we've already seen lists before because we worked with strings. That means anything that we could do with the range, we can also do with the string. So for instance, with the for loop. So if I said for C, or I'll make it more literal for many of you all. So for letter in a string, and this time I guess I'll just use string. And then print the letter. So for this variable in this list here, we're using range before, now I'm using a string. So I want to go in here and pull out each piece. So the letter S, then T, then R, then I, then N, then G. I'm gonna print each one of those. I don't have to use the word letter here. I could use X, I could use I could use Googly Pop if I wanted to. It doesn't matter. That variable is just what's going to be used within the for loop to do calculations. So as you can see here, string. So it went to each piece in here and got it because this is a list, just like when we did range. Okay. All right. And that's because there are some cool things that we can do with list, starting with strings. Don't want to get too ahead for this class, not just quite yet, because all we'll be doing at this point is some nested ifs and elses, and then a nested loop. That's all we'll look at really for this week and next week. So honestly, we've got everything we need for then, and I will probably move on forward next week. Just giving you guys some time to look at things and then go over what happened within the last 3 weeks of assignments to make sure everyone's on the same page. You all want me to keep going? Because I can, and we can go a little further. Or do you guys have any specific questions about loops, for loops, nested loops, while loops, the conditional statements with if, else, if, else, compound operators, strings, anything we've done so far. You guys have anything? Any questions? Okay. Do you guys want me to continue? Oh, for the concatenation, is that only really used in outputs? I'm gonna say no, and the reason is because let's say you wanted to check something. Um, you could you could use it within anything. Trying to think of an example. I mean, there's tons of examples, but I'm trying to think of something that's actually more practical. But let's just say, like with the uh, AdLib thing, the MATLib thing. Let's say you want to check to see if they use a certain sentence, like if they use something that was famous, like for Monty Python, then you could be like, "Hey, that's a quote from Monty Python," or something like that. You would concatenate it together so you could test it. You wouldn't just print it out and then test it again. Um, so yeah, you can use concatenation for more than just how it's going to go out. It's generally you just use it to pull things together. For instance, it's something you guys have done. With the so when we looked at close that so I can see. But for instance, when we looked at the conditional statement, I showed you guys the example with the Celsius and Fahrenheit. I could use concatenation to build the print sentence throughout this entire thing. I could use concatenation to take the unit here, take the degrees being converted, and I could be building the sentence with that. So after the unit, I could say like sentence sentence equals the unit, and then go to the degrees part here, which gives me the number, and then say sentence equals degrees plus unit. So now I got like if I had 40 degrees here, it would be like, and say it was doing Celsius, so it would be 40 Celsius here at that moment. Actually, let's just do it so you guys can see what I'm talking about. I'm gonna do that right there. I don't want all that to print out at the same time. So go back up here. We'll do the basic one here. Actually, I'm gonna change this up in a minute anyway. Okay, so what I could do is say like the sentence equals the unit. So if they put in C, for instance, then this would be C. And then once they get their degrees, I could say sentence equals degrees plus the sentence we had previously. So I'm adding this to the front of it. And then if it's C, I could do my conversion thing, but I could print out convert, and now here's sentence already been created, which is that first part up there, and I do my conversion here. Else sentence here. Okay, let me run that so you guys can see what it looks like. So I'll put F. How many degrees to convert? Let's just do 0. Where did that say it messed up? Type float. Did I get rid of the float? Oh, that's what it was. str. There we go. Right, do that again. So we got F, we got 0. There we go. It took 0 degrees Fahrenheit and made that negative 17 degrees Celsius. And so what happened is, as I move through here, instead of me building this at the end, I could build it as I go down. And that's kind of a hint for your concatenation assignment, actually. You can build it as you move down instead of all at once at the end. Either way, it will work the same. As you can see from this example, we didn't have to build this up and then add it at the last bit in here at the end. We could have built all this at the end. But it works either way. Which one is better code? It honestly depends on what you're doing. because in this case I can use this stuff in two different locations, instead of just it being calculated each time. Whenever you are repeatedly using stuff, you usually need to save it as a variable somehow, or do a loop. Uh, so that's how concatenation could be used in another way without just worried about the output. And I also could use that then, like I said, to test something. For instance, if it was negative 40 degrees, I may test that and say, hey, did you know that's the same? Like use it to add something extra to the output or something, or to cause it to test for an error. So, did that answer your question? Welcome. Okay. So I'll be honest with you guys. Like everything we've gone over is essentially everything that you need to be a programmer. Uh, so you'll notice like the next couple assignments, I think I already opened up next week's. You probably could get a good start on that. So once you finish this week's, I suggest go ahead and look at next week's and getting a head start. That way, when we come back in Monday, you may have some questions specifically about that. It's like, hey, I went through this and I was trying to do it, and I had this issue or I had this issue. But everything that we've talked about is enough for you to get through that. And be honest, majority of the class, this is majority of what you need. This is the baseline. The only other thing left is to understand what lists are, which we're kind of starting to see. Like with the range function, it'll build that list of numbers that you can use. Uh, the strings are lists. We'll see other ways to form different types of collections of lists with arrays, lists. We'll look at dictionaries too later. Sets is not a part of your curriculum, but I'll just tell you about it because I can. Um, and how we can use those within a for loop, but just period, what else can be used with them. So we'll talk about that and some other things you can do with strings. But that honestly is it. The only thing after that is just functions and then building functions and different things you can do within a function, and then other special modules that you can use throughout within Python. And there's just so much. But like I said, everything we went through so far is like the baseline. If you get these skills down, and that's why we spend so much time with it, you'll notice that some of these assignments you're like, wait, I probably could have done this weeks ago. And that's true, you could have. But the point is just so you can continue to build these, because this is the basis. This is it. To be honest, this is really all you need. Everything else is just special ways you can use what we've just learned. How to use loops, how to do loops, um, how to the different data types you have, like your ints, your floats, your booleans, your strings, how to manipulate them, how to compare them, how to do conditional statements, um, and then lists. That's literally that's everything that you need to be a successful programmer. Um, Outside of that, understanding what objects are, which I mentioned today, that a string is has its own module and it has its own special methods that go with it because it's its own object. Um, we're gonna learn how to create objects as well, create our own. But there are tons that are built in already. Like each one of the data types is its own object. They have special methods that you can use on them, special things you can do with them. Like every integer, float, um, and the booleans too. There are special things you can do with them. Notice the different operators we use with them. They were special to those, and they did something different, right? We can use the plus sign. We can use with integers, and it adds them together. When we use it with strings, it concatenates them together, right? We saw with multiplying, it will multiply the number. Use the multiplication on a string, it will print that out multiple times because it still sees multiplication as repeated addition. What is addition with a string? It's concatenated, so it concatenates it multiple times. Um, so yeah. So all right, guys. I normally don't in early. We got 3 minutes. Does anyone have any questions at all? Anything? Yeah. No, I bet. Yeah. We went over a lot. But as you can see, it all goes together too. So if you don't understand the Booleans, you won't be able to do the if else and elif. You won't be able to do a while loop either. If you don't understand a while loop, it'll be more difficult to understand a for loop. But you won't be able to understand a for loop unless you understand how to use something for it to loop over. In this case, we use the range function to start, but we can use other lists too. It just has to be some type of collection. So all of this goes together. That's why I wanted to teach it together. But yeah, like I said, some of this will go over again, and we'll see it over and over again. So it'll get into your brain, and the more you practice and do different things, it'll be solidified. So don't worry too much about it. You have more than enough to complete your assignments for this week, and have some fun. Go back and look at last week's assignments to see what else could you do with the pennies to dollars. Could you do it a different way with some of the stuff we just talked about too? Is there a different way to do it with the while loop maybe, or with the if statements? What are ways to make the program even better? You don't have to even turn them in, just something for you to practice for yourself. So, all right, I will see you all next Monday. You have a glorious weekend. Enjoy it to the fullest. Have fun programming, and email if you have any questions. Text is available as well. Email is likely to get seen faster, but maybe not. Call if you need to too. Whatever. So you guys have fun, and I'm gonna have fun programming too. So thank you. I'll see you guys next time, next Monday. Thank you. And I love your comments. I love your comments in your code, by the way. Both of you particularly. I love your comments. And the way you code things too. I love it. So keep that up. Other people that will be watching this later, you all do great things too. So I'm not trying to single anyone out particularly. Just because they're here, I'm letting them know that is great. I love it. All right, I'll see you all.